we need to understand is what is complex locant. Now, there are some compounds that will contain a substituent, and then that substituent is going to contain another substituent. Such compound is referred to as complex locant. You can basically say complex locant are substituent inside substituent. That is, there are substituents that contain another substituent. So that's basically what complex locants is. And they, in some ways, they actually modify the nomenclature of hydrocarbons or any organic compound. Now, let's say we have, for example, we have a complex locant, and let's say in this case we have something like this. A carbon is here, then we have carbon is here, we have carbon is here, right? And then we have an attachment here. Substituents are basically compound with an attachment. You understand? They will have a bond, an unused bond that they are going to use to attach to the main organic compound. Now, in this case, if you see this kind of compound, what is it called? This is basically isopropyl. Right? So whenever you see a compound and you see this kind of structure, and it is attached to the main compound, this is basically isopropyl. Now, let's say we have another one, and in this case, we are having carbon is here, right? Connected to another carbon. Then we have another carbon here. Then at this point, we have another carbon here. Then we have a single bond here, like a free bond here. So this bond is actually what is going to be used to connect to the main organic compound. Now, if you look at this, we're having 4 carbon atom here, and we're having 3 bond here. Everything here, all the carbon here will be fully filled with hydrogen actually, except this one, except this bond that you're seeing here. So in that case, since this bond is on carbon number 2, right? If I start counting from this 1, 2, or carbon number 2, right? We call it secondary or sec-butyl. Sec-butyl. You understand? That's basically the name. So whenever you have something like this, it's basically sec-butyl. And whenever you have something like this, it's basically isopropyl. Now let's say we have another one here. Look at this. And in this case, this carbon here is moved to the middle side. No, we are going to have the bond here. We are going to have carbon here, another carbon here, and then we're going to have the carbon. This carbon here is now connected to the middle side, and we are having the bond here as well. So in this case, you're going to call this isobutyl, rather isobutyl, right? Whenever we have 3 carbon atom, like 4 carbon atom, for example, look at this 1, 2, 3, 4. That's butyl, right? It is basically sec-butyl because it is at the second carbon, right? Then isopropyl, it is 3 carbon atom. Right, that's isopropyl, and then what happens is that the bond is at the middle carbon. Here as well, you're having 4 carbon atom here, and then if you look at this, the carbon is actually shifts to the middle side. That's basically isobutyl, right? Isobutyl. This is basically isobutyl. While this one is sec-butyl, this guy is isopropyl. Now, another one that we can have is when we have 4 carbon atom, right? And then at this point, we are having we're having a bond here. And then there's another carbon here at this point. So in this case, you call this, since it is 5 carbon atom, you call this guy here isopentyl. This isopentyl, right? Isopentyl. You can see it's in another form. You can see it's in this way. Let's say carbon is here, then the bond is going to be here, right? Then you're going to have, at this point, you're going to have another carbon here, then carbon is going to be here, another carbon is going to be here. This isopentyl. Right, so whenever you're naming any organic compound and you see this kind of substituent, it is called isopentyl. This guy is called sec-butyl. This guy is called isobutyl. While this guy is called isopropyl. And the reason why they are referred to as complex locants is because there is a substituent inside the substituent. That's what we have. Everything that you're seeing here is a substituent. There's another substituent here, which is this methyl that you're seeing here. This is another substituent. This is a substituent. Everything that you are seeing here is another substituent on its own. So that's why they are referred to as complex locants. Now let me just simply clear this off so that we can actually see space to write the other ones. So another one that we can have, right, is when we have carbon is here, right? You have a carbon here, then a bond is here, then we have another carbon here, then we have another carbon here. So this guy here, we see this kind of this guy is called tertiary, or you simply say tert-butyl. There is difference between isobutyl, sec-butyl, and tert-butyl, right? This is tert-butyl, right? Don't mix it up, right? In the case of isobutyl, right, it's actually let me say the bond is the carbon is at the middle, right? That's isobutyl. And in the case of secondary butyl, it's at the first side. So whenever the carbon to which the bond is attached to is directly connected to 3 other carbon, that's basically tertiary. And in the case of carbon, in the case of what, of secondary, let me say the bond here, right? This is another one. This is secondary, right? The bond here is connected to this carbon, and this carbon is directly connected to these two other carbons, right? That's why it is called secondary butyl, right? Secondary butyl. And third butyl, because the bond is connected to this carbon, and this carbon is connected to three other carbon. That's why we call it tertiary butyl, right? That's why it's tertiary butyl. So in the case of isobutyl, right? Isobutyl, which is this case that you can see here, this case, right? The carbon, like the bond here, the carbon here, the bond is at this side, right? And then look at this very well. This bond, this carbon here is attached to this carbon and this carbon, right? So since it is at the middle, that's why it is called iso. You can always rewrite it. That's basically isobutyl. So you should be able to differentiate between tertiary butyl and sec butyl, right? Now let's continue. Let's say we have one more, like we have one more here, right? Let's say we have this guy here, right? We have carbon here, and at the same time we have carbon here. Then there is a bond here. Right, so if we count it 1, 2, 3, 4, 5. So this 5 carbon atom. This is basically neopentyl. 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 That's basically the name of this guy. So now these are the complex locant that we have. The most common one. These are the ones that we have. So I'm going to move to nomenclature of complex locant. I'm going to move to nomenclature of organic compound that actually contain this complex locant. Then we see how we can actually name them. Right? Now, first question that we have. Look at this structure very well. It's actually a skeletal structure, but you can see we have a complex locant here, and at the same time we have a complex locant here. Now, how can you name a complex locant? A complex locant is actually named, or let me say it's actually written inside a square bracket, right? And then we always use the word di, tri, and tetra. You understand? Depending on the number of complex locant that we have, right? So, and then it is used in alphabetical order. For example, we have di, we have tri, we have what? Tetra. You can always use what in alphabetical order, right? So that's basically, and at the same time, the iso, neo, sec that I actually mentioned earlier, you also arrange them in alphabetical order. Now, if you look at this case that we have here, it's very, very simple. It's still normal naming, just have to number forward and backward, right? If you start from here, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And this is 9. Then if you number backward, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, and 9. I think numbering backward is going to make sense. Why? Because our attachment is on what? Is on 4, and then is on what? Is on 5. The attachment is what? Is on 4 and 5. And then if you look at the attachment are quite similar. They are the same. They are referred to as complex locants because they are substituent inside a substituent as well, right? Now look at this. This I'm going to name them. Here is going to be, since I'm having on 4 and 5, I'm having what? An attachment. I'm going to have 4, 5, right? So since both of them are similar and they are the same complex locants, I'm going to use the word bis. Bis represents two things. You understand what I'm saying? We have bi, we have bis, we have bi as well. So in this case, I'm going to have 4, 5 bis, then open a bracket here. Then once you open a square bracket, so the name of this guy, that's actually where you're going to write it. You know, we have something like this, right? And then if you look at this very well, this is basically carbon 1, carbon 2, and carbon 3, right? Carbon 1, 2, and 3. That's basically what we have. You look at it, this is what we have. Right, 1, 2, and 3. Then how can you go ahead and name this kind of compound? On this position, we're having what? We're having 2 methyl group, right? We're having 2 methyl group attached to this position. This is the bond, right? This is the bond, right? And then at the same time, if this guy is the bond that it's used to attach to this carbon here, this carbon at this position, the one is going to be this guy and this guy. They are going to be methyl group. Abinam. So that's why we're going to have carbon here, carbon here, carbon here, and at the same time we're going to have carbon here, right? So 2 carbon atom in this case. Let's say we have 2 carbon atom. Let me just write it as this. Let's say we have something like this, right? And also we have something like this. This carbon here, and this is a bond, right? So in that case, we're going to have on carbon number 1. This is going to be our carbon number 1. What do we have on carbon number 1? We are having one methyl group and another what? Methyl group, right? That's actually what we have, right? So we're having one methyl group, another methyl group, and the longest carbon atom is basically what? 1 and 2. You look at it very well. If I number like this, I'm going to have 1 and 2. This 1 and 2. And on position 1, I'm having what 2 methyl group. So what does that mean? I'm going to have 1, 1, right? Then we're going to have dimethyl, because this is carbon number 1. This is the attachment. This is the bond that it's used to attach to this carbon here. 1, 1 dimethyl. Then what's the longest carbon atom here? That's ethyl again. That's why it is referred to as complex Locants, because there is substituent inside a substituent. So we're going to have 1, 1 dimethyl. Then we are still going to have ethyl again. You close the bracket, right? Then what's going to be the last name? You now come here. We are having 9 carbon atom. That is nonane. So we're going to end it with nonane. So this is basically 4, 5 bis, open a bracket, 1, 1 dimethyl ethyl nonane. That's the name. You understand? And the reason why is because that this bis basically represents these two substituents that you're seeing here. They are the same. So that's the. So now let's take a look at this question that we are having here, right? So we are still going to number forward and backward, right? So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? So backward at the same time, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Now, if you look at this very well, we have to consider something here, right? Because we have a substituent, right? We have a substituent at position, that is 7 and 5, rather. We have something at position 7 and 5, right? So what we are going to do is that since we are having 12 carbon atom, right? 12 carbon atom, sorry, please, this is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. This is 5. This is 6. This is 7, 8, 9, 10. This is 11, and this is what? 12. So you have 12 carbon atoms. So 12 carbon atoms simply means dodecane, right? That's 12 carbon atom, dodecane. So what now happen here is that if you look at this very well, numbering forward here will not really favor us, in the sense that it's not going to give our substance the lowest possible number. But if you number from this side, 1, 2, 3, 4, 5, 6, the substance is at position 6. And don't forget, this is how the substance is. This is what you have. So this is the attachment bond, right? In that case, you're going to have carbon is here, carbon is here, carbon is here, then another carbon is here, then you have something like this. So in that case, you're going to have this carbon number 1 and this carbon number 2. So on carbon number 1, you have 2 substituents. This is the main carbon. You have 2 other substituents there. So in that case, we're going to have this to be, this is going to be 1, 1. We are going to have dimethyl, right? Then ethyl at the same time. Dimethyl, ethyl. So that's basically what we're going to have. So now let's come back here. So since what we are going to have here is basically 1, 1 dimethyl ethyl, we're going to put it here. That's going to be at what position? We are having it at what? At position 6, right? So this is going to be 6, open a brief bracket, right? This is going to be 1, right? 1. Then we're going to have dimethyl, right? Ethyl. Then you close brackets, you're going to have dodecane, right? So that's basically what you're going to have. 6 into bracket. 6 simply means on the main compound, it is attached to position what? Position 6, right? Then 1, 1 dimethyl, right? Dimethyl ethyl represent this particular substituent. Then dodecane simply represent what? The parent chain. So that's what we have. Now let's go ahead and name another compound. Now look at this compound. How can we name it? You look at this. Let's basically number forward and backward. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then backward, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, and 9. It shows that whichever way we try to number it or to name it or to count the carbon atom, it's actually the attachment is actually what? On position number 5. Now the attachment is something like this. We are having the bond, then we're having a carbon here. The carbon is here. We're having this one is attached to this guy here. We're having a carbon here, and at the same time a carbon here. So what we have to do is actually to go ahead and check for the longest carbon atom here, right? So if you look at this very well, this is basically the attachment bond. So we're going to count from here. 1, 2, 3, right? 3 carbon atom that you're seeing here. from the, you can't like the longest chain from the attachment bond. The attachment bond is going to be carbon number 1. Get it right. So this is where the attachment, this is where the carbon, like the attachment bond, this is carbon to which the attachment bond is what is attached to. We're going to have it to be what, to be 1, 2, and 3, right? Then from here, since 3 carbon atoms separately represents propyl, is a substance, we're going to call it propyl, right? Then if we call this propyl, then what's going to happen to the guy? Just so that this guy is attached to this carbon number 1, and that's basically 1-methyl propyl. 1-methyl propyl. That's basically what we have, and that's the name of the attachment. So it is basically 1-methyl propyl. Now we now come back here. Since we are having 9 carbon atoms separately represent nonane, right? So we're going to have nonane. Nonane is what we have here. Then our position number 5, we are going to have 5, then open a square bracket, 5, then we're going to have 1-methyl, right? Then we're going to have propyl, then close it, then we're going to have nonane, right? That's basically 1-methyl propyl nonane. That's what you're going to have, and that's going to be the name of this compound. Now let's go ahead and name another one. Now if you take a look at this compound that you're seeing here, right, it's somehow complex a little bit, but what we just have to do is just to go ahead and count the longest carbon atom, right? Now if I'm taking this as the longest carbon atom, I'm going to have 1, 2, 3, 4, 5, 6, right? That's going to be the longest carbon atom. If I count like this, or moreover, if I choose to count like this, I'm going to have 1, 2, 3, 4, 5, 6. Whichever way I actually count, it is 6. 1, 2, 3, 4, 5. That one is 5. I cannot follow that way. Then 1, 2, 3, 4, 5. I cannot follow this way as well. So let me basically follow this guy this way. 1, 2, 3, 4, 5, 6. Right? If I follow that way, I'm going to number forward and backward. 1, 2, 3, right? Then 4, 5, and 6. And at the same time, this is going to be 1, 2, 3, right? This is going to be 1, 2, 3, right? Then we're going to have 4, 5, and 6. So whichever way I try to count, let me simply say substituent is on position 3 and 4, and at the same time on this side as well, it's also on position 3 and 4. That's what it is. Now let's look at this. Let's consider let me simply say the forward. We are having 3 here. Then what is this compound? This compound is, we have something like this. This is a carbon, then a carbon is here, and at the same time a carbon is here. Then what does that mean? Right? What does that mean? Like this compound, what does it mean? It basically means this 1 and 2, right? 1 and 2, this 1 and 2, and then because you are going to call this guy carbon number 1, because attachment is actually the bond is attached to this guy here, and that's carbon number 1 and 2. So on position 1 we have another methyl group, so that's going to be 1-methyl, right? This is 1-methyl. Then what we have here is actually what? Ethyl. 1-methyl ethyl. That's what we have. Then apart from that, what we have here on position number 4 is actually ordinary ethyl group, right? So that's basically what we have. So this is basically ethyl, right? Carbon 1 and carbon 2. So this is basically a bond connected to 2 carbon. That's what we have, and that's what we are seeing here. So in that case, let's try and name everything all together to see what we're going to have. I'm going to name it twice actually. I'm going to name it twice, like to see what we are going to have. So in that case, let's say this is basically 1, 2, 3, 4, 5, 6. 6 is actually hexane, right? This hexane. Then from there, on position 3, I'm having 1-methyl ethyl. Then I'm going to have it to be 3, open a big bracket here, or let me simply write it out here. I'm going to have 3, open a big bracket. We're going to have 1-methyl, right? We're going to have ethyl again, then close this big bracket. Then followed by, we are having ethyl here. Then we're going to have 4-ethyl. Then we're going to have hexane. That's what we're going to have. That is 1-methyl ethyl, 4-ethyl hexane. Now that's basically if I count it towards the side. Now let's consider, let's say I'm going to write it out now and count it in another way round to see what we're going to have. Now look at this. Let's count it in another way round. Let's count it like this. Let's say we count it like this. We have 1, 2, 3, 4, 5, and 6. Right? Now, if you count it like that, what do you notice? Let me just count it forward as well, backward as well. This should be 4, yeah. Okay. This should be 5 and 6. So let me just count it in this other way around. Right? So in that case, I'm going to have this to be 1, 2, 3, 4, 5, and 6, right? So if I try to count like that, what am I going to have? I already know that I'm having 6, and what does 6 means? 6 is basically hexane, right? That's hexane. Now, what position am I going to consider between 1 and 2? This is 2, and this is what? 3. 2 plus 3, right? That's what we have. 2 plus 3, then plus again we have 4. That's basically what? This is basically 9. Then let's consider another one. We're having what? Counting from here, we're going to have 3 plus, we have, that's going to be 4 again. Then plus, we have 5. This is actually 11. So 9 is actually making sense for us to consider. So if you count like this, that's so that on position 2, we're having what? Methyl group. And then on position 3, we're having a T group. Then on position 4, we're having another what? A T group. So this is going to be 3, 4, right? Diethyl. Then after diethyl, what do we have? We're having what? 2 methyl, right? 2 methyl, then hexane. So this is basically the name of what? Of this guy here. This is basically the name, right? So if you count like this, you're going to have another name, right? You're going to have another name. But if you count like this, you're going to have another name. If you count like this, you're going to have another name. So that's making sense. So this should be the right way. We're going to have 3, 4 diethyl 2 methyl hexane, and that's the right way. Now let's go ahead and name one more question, right? Now if you look at this, we can actually now count the carbon atom in this side, right? You can count it like this, and at the same time you can go ahead and count the carbon atom like this, right? You can count it like this as well. It's also making sense. Now let's go ahead and count it just like this. We're going to have 1, 2, 3, 4, 5, 6, 7, and 8, right? That's what we have. And on position 4, we have what? We have an attachment here. On position 2, we have an attachment here. And on position 5 as well, we have an attachment here. So what we are going to do now is that it's very, very simple actually. We can just go ahead and let me simply say, follow this side, right? And if you look at this, this is basically 1, 2, 3. On position 3, we have a methyl group, right? On position 3, we have what? We have methyl group. That's going to be methyl groups on position 3. Let me just write this out. Then followed by, on position 4, we have, this is going to be 1, 2, 3. This is propyl. We have propyl. That's what we have on position 4. We have propyl. Then on position 5, we are having isopropyl. That's what we have on position 5. This is basically isopropyl. Or better say, if you want to go ahead and name it, right? If you want to go ahead and name it, you're going to have a bond is here connected to carbon. You are going to have one carbon here, another carbon here. So this is going to be 1 methyl, right? 1 methyl ethyl. That's basically what you're going to have. 1 methyl ethyl, right? That's what you're going to have. And that's basically at position, that's 5, right? So in that case, and if you count from here to this side, everything is what is 8 carbon atom, which is basically octane. So what I'm going to have here is going to be 3 methyl, right? I'm going to have 3 methyl. Then here is going to be, since I'm having, after this methyl, this isopropyl, and isopropyl comes before propyl itself. I comes before P. I'm going to have 5, you can just say isopropyl, right? 5 isopropyl, then followed by 4 propyl octane. That's going to be the name. Or better still, you go ahead and name it in this way. You're going to have this is going to be 3 methyl, right? 3 methyl. Then you're going to have 5 open a square brackets 5. Then you're going to have 1 methyl, right? You're going to still have ethyl again. Then close the bracket. Then you're going to have followed by 4 propyl, right? 4 propyl. You're going to have octane. So whichever way you name it is actually what right. So that's just the right way for naming this compound. So that's just it. So I'm going to write one more question out for you guys to solve. Then you're going to drop the answer, the name in the comments box below. Now let's go ahead and check it out. Go ahead and name this guy here, the first one. Then let me just give you one more. So go ahead and name this one as well. It's very, very simple. You can as well, you can just drop the answer in the comment box below, right? I'll be there to also reply you guys. So that's just it. So the first one and the second one. So that's all the question, all the video under complex locant. So the next video is going to be IUPAC of functional groups. So that's exactly what you're going to make next. So if you enjoyed this video, don't forget to like, share, and subscribe. Thanks for watching.